Question number 1 of the circle equation worksheet. The diameter of a circle C1 has endpoints -3, -5 and 7, 3. Let me try to show this here. So let's say this is the first point, -3, -5, and the other end would be this 7, 3. And these are the two opposite ends of the diameter of the circle C1. Find an equation of circle C. Okay. So now we know that, we know that the circle, to find the circle equation, you need the center and the radius. So I need the center here, which is going to be the midpoint of these 2 points. And then I can use distance formula and find this radius. Okay, so let's find the midpoint quickly. So the midpoint or the center of the circle C1 would be, add both the x divided with 2, add both the y's, divide by 2. I've applied the midpoint formula. So that's going to be 4/2, which is 2, 2/2, which is 1. So that's the center, 2, 1. And now you need the radius. So let's apply distance formula here. So I'm going to do square root y2 minus y1 whole square. So 3 minus 1 whole squared plus 7 minus 2 whole squared. Simplify this and you will get square root of 41. Sorry, I noticed a mistake. This was supposed to be -1. And then this would be +1. So that's the -1 here that I missed earlier. Okay. And now it's going to be square root of 41. Okay, 4 square plus 5 square. Okay, so the radius is square root of 41. We have the radius, we have the center. So now we can write down the circle equation. It's going to be x, change the sign of this x coordinate 2. So it's going to be -2 whole square plus y, change this sign, +1 whole square equals to radius squared. So it's going to be equals to 41, because when you square this, you get 41. Okay. So that is the answer for part A. Okay. I will need to clear this. Part B, find the equation of the circle C2. And what did they tell us about that? That the circle C1 is translated by vector 8, 4 to the circle C2. Okay. Now you've done this in transformation in O levels. If you recall what was translation. So translation by 8, 4 means that you move each point 8 units to the right and 4 units up. So every point on this circle moves 8 right and 4 up. So that means the center is also going to move 8 right and 4 up. That's going to be the new center or the center of C2. So what are we going to get? So it's going to be, take 2, 8 units to the right, we get 10. And then take -1, 4 units up, we get a 3. So 10, 3 is the center of this circle C2. Let me write 10, 3 here. Okay. And the radius is not going to change. The center, the entire circle just went 8 units to the right, 4 units up. That's not going to change the radius of the circle. So the radius is still the same. It was square root of 41. So now this new center or the new circle equation is going to be x minus 10 whole squared plus y minus 3 whole squared is equals to radius squared, so 41. Next is uh, show that, okay, the two circles intersect at point R and S. So you can see that in the figure here. So they're asking us to show that the equation of Rx is equals to minus 2x plus 13. Okay. So we somehow need to form or show that this equation is going to be equals to minus 2x plus 13. All right. So if you look at the original two centers of both the circles, this and 10 comma 3, let me just move the remaining ones. Okay. So look at the center of both the circles. If you connect it with a straight line, then this is going to be the middle of those two centers. And also this is going to be a right angle. So what we're going to do now is find midpoint of 10 comma minus 1, 10 comma 3, and then find the gradient of between these 2 points, between the two centers of the circle, and then take negative reciprocal of that to get the gradient of the red line. And that is how we will form an equation of that red line, and it should come out to be negative 2x plus 13. Let's see. Okay, so quickly, the midpoint is going to be 10 plus 2 divided by 2, comma, minus 1 plus 3 divided by 2. So we get 6, comma 1. Now the gradient of the points connecting the center, y2 minus y1 over x2 minus x1, we get 4 over 8, which is 1 over 2. So the gradient of this line is going to be negative reciprocal of that, which is negative 2. So now we have y equals mx plus c. To find c, we're going to use the midpoint we found, 6, comma 1, which was this coordinate. Okay, so 1 equals negative 2 times 6 plus c. We get 1 minus 12 here, which is going to be, I'm sorry, 1 plus 12 here, which is going to be 30. So the equation is coming out to be y equals mx plus 30. Okay, so we have shown that we also get this. Last part. Okay, last part is show that the x coordinates of R and S satisfy this equation. Okay, so now we have to show that the x coordinate of the point R and S satisfy this quadratic equation. They're not asking you to find the x coordinates. If they would, first you would show this quadratic equation, and then you would solve this quadratic equation to get two values of x, one of which would be the x coordinate of R, the other one would be the x coordinate of S. Anyways, for now, we just have to show that we get this equation. Okay, now look at R and S. From R and S, the this line is passing, this linear line, which is y equals negative 2x plus 13. And from R and S, two circles are passing. So you can take any one of the circle. I'm going to take this one. You can take either of them. So now I have two equations passing through R and S. One of them is this one, the equation of circle C1, that was x minus 2 whole square plus y plus 1 whole squared equals to 41. And the other one is the straight line equation y equals negative 2x plus 30. Use substitution method, replace this y with negative 2x plus 13, expand completely, you should be able to get this. Let's do that quickly. So we have x minus 2 whole squared plus minus 2x plus 13 plus 1 squared equals 41. So we have x minus 2 squared plus minus 2x plus 14 squared equals to 41. Expand x squared minus 4x plus 2 plus, now how do we expand minus 2x plus 14? You may change it to 14 minus 2x whole square, and then this is the identity a square minus 2ab plus b square. Okay. 14 square is, I believe, 196. So 196 minus 2 times 2 times 14, which is going to be 56, and plus 2x squared, so it's going to be 4x whole squared. Sorry, 4x squared. It's going to be a squared minus 2ab plus b squared. Some of you end up making this blunder that you take a negative sign over here. This is absolutely incorrect. There is no negative sign in this formula other than here. Okay. And now this would be equals to 41. Rearrange, you get 5x squared minus 60x. And I'm sorry, this was supposed to be 4, not 2. Okay. And then we have 196 plus 4 and minus 41, which gives us 159 equals to 0. And we got the required quadratic equation.